the second part of our three exponents. We covered negative exponents, multiplying, which is the product property, dividing, the quotient property in the first section of exponents. Now we're going to look at power to a power. So go ahead and write this problem down, 6x to the fourth, and then that whole thing is to the third power. When you're using a power out here, it goes to everything on the inside. So the 6 would be to the third power, and we'd have to take the x to the fourth to the third power also. And we'll talk about how to do that here in a second. So 6 to the third power, which we will calculate. And then when you have a power to another power like this, 4 to the third power, you multiply them. So 4 times 3 is 12. All right, so now we need to figure out what 6 to the third is. Happens to be 216. So we say 216 x to the 12. Just kind of a little reminder on what to do with a power to a power. So our next one's going to be a little bit more involved. Go ahead and write it down, hit pause, try it. Make sure you distribute that exponent to everything on the inside. If you get stuck, you can always then unpause the video and come back and check. But it is good to try it on your own to see if you get the idea. So for this one, everything inside is going to be cubed. Take all of these to the third power. So we have 2 to the third. We have 4 times 3. Remember, we multiply those, so that's x to the 12th. The y has an imaginary 1, so we multiply those. 1 times 3, so y to the third. Then the same thing in the second parenthesis. We're going to take all of these to the second power. Now when we take negative 3 to the second power, we have to put that negative 3 in parentheses because we're taking that whole thing to the second power. And the parentheses do make a difference. Then we're going to take x to the 5th to the second power. So we're multiplying those to get x to the 10th and y squared. So that's step 1, getting all of those exponents distributed. Now we have to do some simplifying and some combining. So 2 to the third is 8, and negative 3 squared is 9, and that's why those parentheses are so important, because we don't want to say negative 9. So that's something that we have to simplify. But then we also want to combine our like variables. You never want to end up with the same variable multiple times in a problem. As your final answer should only have one x or one y in it. If it has multiple x's or y's while you're doing this, it means that there could be more simplifying. All right, so we are multiplying the same base, which means we add the exponents. So that would be x to the 22nd. And same thing with the y's. Add those together, so we have y to the 5th. Now that might look pretty odd to most of us, having an 8 here and a 9 here. So we need to combine those also. All of these things are being multiplied. 8 times x to the 22nd times y to the 5th times 9. So we need to multiply the 8 and the 9 to get 72 x to the 22nd, y to the 5th. Number 8, these are continuing using that power property where you're going to distribute. So everything in the fraction is going to get the 4th power. So the 5 is going to get it, the x is going to get it, the 6, and the y. So go ahead and try that, giving everybody that exponent. Pause it and come back and see if you got it right. So we have 5 to the 4th, x to the 8th, over 6 to the 4th, y to the 12th. Now, we can't simplify our variables because they're different, but we can simplify these coefficients. We can find out what 5 to the 4th is. So that's 625, x to the 8th. and 6 to the 4th is 1,296. Y to the 12th. Now we would want to check to see if there's anything that can be reduced with these coefficients, any like terms. There's not on this one, but definitely want to check that. All right, here's number 9. Go ahead and see if you can distribute that exponent to everything. Pause it, come back, check and see if you got it right. All right, so we give the -6 to everything. So we have x to the 18th, because a -3 times a -6 will give us a positive 18. Y to the -12th, 2 and a negative, gives us a negative. So we have a positive and a negative. And then here another negative. So we have z to the 24th. Now, most of that is simplified, except if you remember, we can't have negative exponents in our final answer. So we have to fix this -12, which we've talked about in the past. In order to fix it, you have to move it. So x to the 18th gets to stay where it is. Z to the 24th gets to stay where it is. So if it's positive, it stays put. We don't move those. But negative was on top as a negative. Now we move it to the bottom and it's positive. Typically when we write our final answer, we try to keep things in alphabetical order as much as possible. So I would say put the y to the 18th before the z to the 24th. That would be the more common way to see that. And if you're entering answers into a computer, sometimes you have to use the caret button to do an exponent. Here's our last one, number 10. Go ahead and write it down. Hit pause, give it a try, come back and check. All right, we're going to distribute that 2 to everything on top. So we have x to the -6, y to the 10th. On the bottom, nothing changes. So we did our power to a power rule first. Now we need to combine. We're dividing. So dividing means that we are going to subtract. So -6 minus 6 gives us x to the -12th. And again, we're going to subtract here. 10 minus a -3 would really be adding 3. So y to the 13th. All right, we take a look and we have that negative exponent there, which we don't want. So we are going to move the x to the 12th down to the denominator. Notice that the y to the 13th is positive, so it stays where it is. If it's positive, it doesn't move. Negatives move. Now, some of you may have done this problem differently. Maybe instead of subtracting the exponents, you moved the negatives. So let me show you another route you could have taken, because that would have been okay. So maybe you moved the x to this -6, maybe you moved it down here. And maybe you took this y to the -3 and moved it up there. So perhaps your second step looked more like y to the 3rd, y to the 10th, over x to the 6th, x to the 6th. That's okay. Because you'll see that once we add those together, same base means we add the exponents, we get y to the 13th over x to the 12th. And it's the same answer. So either way would work. You could either subtract or you could get rid of the negatives. And that's what's cool about the exponent rules, is there's lots of options for you.